So let's look at a pretty interesting question. We are given two strings s and t and want to return true if they are equal when both are typed into an empty text editor. Sounds easy, right? Then we are given the extra constraint that the s and t can, they are strings, they can contain the pound sign character, which means a backspace character. After backspacing an empty text, the text will continue empty. Let's look at some examples to make this a bit clearer. So we have AB pound sign C and AD pound sign and C. And so we are told that any number that comes before a pound sign is removed. So B comes before this pound sign, so we remove it. D comes before this pound sign, remove it, and now we are left with AC and AC, which are the same. Let's look at the second example where we have AB pound sign and C pound sign D pound sign. For every pound sign, we remove one letter. We have one pound sign, remove the B. We have another pound sign, remove the A. So we have an empty string here. This pound sign eliminates the D. This pound sign eliminates the C. We have an empty string which are also equal. And then finally, let's look at the third example where we have A pound sign C and then the B. So pound sign removes the letters that come before it, so we remove A. Now we're left with C and we're left with B, which has no pound sign, but they are not equal to one another, so we come up with a false. Now let's consider how this would translate to code. So let's consider that we are given AB pound sign C and AD pound sign C. How are we going to translate this to code? So the first intuitive way that I might do is to trim each individual letter. So we want to strip all of this down of the backspaces and pound sign, and then we want to do that for the second string and then compare if they are the same, right? So we can go ahead and start from the last item, the last number in the given string. Not the last number, I keep saying number, is letter, the last letter in the given string, and then we check do we have any pound sign before it. No, we don't. It is the first letter, so we append it to a new string. Basically, let's call this new string, and then we have our C. And so we move on to the next letter. We can see that we have a pound sign. So what do we do here? We can keep track of the number of pound signs that we have encountered. So at this point, let's say we have a pound sign tracker that is set to 0, but now that we've encountered a pound sign, we can then increment it to 1, and now we have 1 pound sign. So we move over to the next letter, and then we check, do we have any pound sign, like is our pound sign tracker greater than 0? And yes, it is. So because our pound sign tracker is greater than 0, we know that we've encountered some pound signs before, and so this should not exist in our new string. And then we also decrement our pound sign tracker back to 0 because we've used that backspace. And then we move over to our last letter, and then we have A. So we have CA here. Now this is more intuitive than starting from the first letter. So let's assume that we start from the first letter here, and then we append A to our new string. We move over to D. We append D to our new string, and then we move over to the next value, and it happens to be a pound sign. So then do we now go back to our new string tracker and then remove the last letter we added? That's not very intuitive. It just makes sense to not have added the letter at all to our new string builder. And so that is why we are starting from the back here. So we start from the last letter. Once again, we have C. We move on. We can see that we have a pound sign, so we increment our pound sign tracker to 1. We move over to the next value, and then we check, have we encountered any pound sign before? And yes, we have. So we skip over this, we do not add it, and also we've used this pound sign tracker, so we deduct it to 0. And then we move over to our last letter, which is A, and then we have CA. We check if our first string and our new second string are the same, and they are. And you can see that it really does not matter that these strings are basically in reverse, because they are going to be palindromes if they are the same. So they are going to be palindromes if they are the same, and so they are going to be the same whether reading from the front, reading from the back. So we don't have to go through the extra hassle of reversing the string, because as you can see, AC AC, CA, CA are obviously going to be the same thing, so we don't have to worry about that. Now let's look at another example. So we have the AB pound sign, and the C pound sign, D pound sign. Again, we start from the last item, and we can see that this is a pound sign, so our tracker is 1. We move over to the next item, our tracker becomes 2. Move over to the third item, and before we add this to our new string, we check, have we encountered a backspace character? And yes, we have. So we skip over this, decrement our pound sign to 1, and then move over to the last item. We see that we still have 1 backspace character, and so we come up with an empty string. We don't add anything to our new string builder. We do the same for our second string, where we go to the last item, we check, is this a pound sign? Yes, a pound sign. So we increment the tracker to 1. We move on to the next one, where we see that this is a letter, but we have encountered a backspace character, so we skip over this. We do not add it to our new string builder because this character means backspace, empty read. So we move on, and then we encounter a new backspace, a new pound sign. This had gone from 1 to 0 when we encountered this, but now it is 1 again. And finally we move over to this tracker, and we can see that to the next letter, not tracker, to the next letter, I can see that this is a C, but because we have 1 backspace character, it cancels out this, and again we end up with an empty string. So the resulting value, or the resulting boolean, is going to be true because an empty string is an empty string. Let's assume this was not a pound sign and this is the letter D or A, however you see it, and then we start with the pound sign tracker, which cancelled out this D, and then we are left with C and D. We can see that this empty string is not equals to this letter CD, so we would return a false. Now the time complexity for this is O of n plus m, or in this case O of s plus t, or O of n. This algorithm can be written in 2 different ways, and the time complexity of both ways of writing it depends. One is O of n plus m, and one is O of n, as we will see in the walkthrough video. And the space complexity is constant, regardless of the fact that we're using new string. And you may ask the question that we're using a new string to keep track, but it really does not matter if you think about it, because we are using a variable, not an extra data structure. The variable using is temporary. We're not going to be storing anything like that in space, and also in memory rather. And also the variable cannot grow larger than the input given of whatever strings that we're given. If we have A, B, C, D, E, and we append all of that to our new string, it cannot grow beyond that. So we're not using that significant space in memory, so it's negligible. Or it can also be linear, regardless on your interviewer. You can ask them, using a variable, does it count? If it doesn't, they can pass as constant space, but if it does count, then that will have to be a linear space complexity. Now let's jump right into the code. Let's write some code, and the algorithm for this code is going to be simple. First, we are going to trim down the strings, and then we are going to compare. So to trim down the strings, I'm going to be using an helper function. I'm going to call it trim. Let's call it trim string, just in case there is anything like that in memory. And I'm going to pass in string as a parameter. And so let's define all the variables that we'll be needing. Since we are starting from the last item in our string, we're going to be getting that pointer. So we'll call it I'm going to call it pointer ptr, and this is going to be the string the length -1, so basically the last item in the array, since that is where we're starting from. Also going to define the skips. So the skips basically is keeping track of the number of pound signs that we have encountered, and this is going to be initially set to 0. And we're also going to be defining the new string, and so the new string basically is our builder. Okay, I think let's call this new string. Fine, so new is a reserved keyword, and so new string is going to be the new string builder that we're going to be using. Now let's go ahead and write our code. We're going to check that while this is in bounds, while pointer is greater or equal to 0, because 0 is the first item in our string and doesn't make sense to go beyond that. So while this is 0, we're just going to make the necessary check. So what checks do we want? We want to check that if the current item that we are on, if it is a pound sign, if it's a pound sign, what do we want to do? So we want to go ahead and increment our skips. That means we have encountered a pound sign, so we want to increment this number of items to skip. So we're going to increment our skips. I'm also going to move ahead with our pointer, and that is just decrementing it. So since we're starting from the last item, so we're decrementing, we're going down. And now if our skips is greater than 0, we want to go ahead and first decrement the skips. That means we want to use the skip, and then we also want to just move on. But if it happens that our skip is not greater than 0 and we are encountering an actual letter, not a pound sign, we want to add that letter to our new string builder, and we also want to go ahead and move on by decrementing the string. So we have a lot of string decrements going on, so I'm just going to go ahead and make that a global operator for this while loop. So I'm going to delete this everywhere. Now that this is done, we've trimmed our string. What do we now want to do? So I'm going to call this strim. So we want to call this helper function on each of the variables given. So strim, want to call the trim string on s variable. Then we're also going to call the trim. We're going to call it on the t variable. So basically we're trimming the s variable and the t variable, and then after they've both been trimmed, we can then check if they are the same by just checking that strim is equal to trim. If they are not the same, we get a false. If they are the same, we get a true. So let's go ahead and submit this. And it says that this is a wrong answer. So let's look at what we might be doing wrong here. Okay, so I've seen what we are doing wrong. We are not returning anything. Like, as you can see, we ought to return the new string that we have built in our trim string helper function, but we're not returning anything. So let's go ahead and return that. I'm going to go ahead and return new string. So I'm going to submit this one more time. And as you can see, this is accepted. The term complexity of this is O of n plus m, because we are distinctly running this function on s and t. We're running them separately. So we're running s and running t. If we want to do this in O of n time, we just have to create a big while loop and run them consecutively. So let's do that, and we'll see how that compares to this. Personally, I prefer this technique because I think that it is much more easier to read and understand than the O of n time complexity, which uses multiple loops. So now that we're going to be creating a joint while loop for checking the s and t strings concurrently, we'll no longer need an helper function. Instead, we're writing out the code for both strings. So I'm just going to call this s pointer and t pointer, just getting the length of both. And it's going to be s dot length minus 1 and t dot length minus 1. Then we're also going to go ahead and define their skip. So s skip and t skip. I hope I'm not making any errors here. So s skip is going to be 0. This is just the skips that we've encountered for both, and it's going to be by default 0. Then we're also going to have the s new for the new string we are building, and the t new for the new string that we are building, and they are initially going to be empty strings. So now I want to run our while loop while either of them is still valid. So okay, I think it's pointer, while s or pointer is greater or equal to 0, or p pointer, I think it's t pointer, is greater or equal to 0. They want to run them concurrently, and I'm just going to go ahead and also separate them out. So I'm going to say that while s pointer is greater or equal to 0, while it's in bounds, and yeah, I'm just going to repeat that whole helper function that we wrote in the previous code. I'm just going to write it out for the s pointer. So this is essentially the same thing that we had with our helper function. We're checking if it's a pound sign, then we are skipping. If it's not, then we also want to deduct the skip number. We want to move on with the pointer. And if it's a letter that has no skips, then we want to append that to our new variable. And the only difference I think is the curly braces that I've omitted. And so I'm just going to copy and paste this exact code for the t pointer too, for the t string, just trimming it too. Now that we've already trimmed both our s string and our t string concurrently, I can go ahead and check if the new string built is the same. And if we go ahead to submit this, we can see that this also runs fine and is accepted. Thank you so much for watching. I'll see you in the next video.